Welcome back. So this time we're going to use some linear regression. Now, you might say we've already got a linear regression equation, and that's true, but there is a better version of this which gives us more access to more detailed information. Now, I'm going to, first of all, find the mean value of all of these different x coordinates. So I'll use the average command, and I'll do the same for the y coordinates. And I'm going to insert this coordinate pair in the middle of my graph. It's not a data point, it's a calculated point. So how do I insert extra points? I click the chart, I go to chart design, select data, and I will add a data series. The x value is that single number, the y value a single number. And OK. Now there it is, it's that orange dot. If I go to the Format tab, it will be Series 2. It's a series with just a single dot. I'm going to change the marker to have no fill-in color, but it will still have a little outline. There it is. So when we used to do this by hand, before computers, we would always put that average value in the middle of our chart. It must land exactly on the regression line. Even though the data points might be a little above or a little below the best fit line, that average value always exists exactly on the regression line. That's part of the mathematics of regression. Now, we used to plot that first, put our pencil on that spot, and pivot the ruler against the pencil until we were happy with the position of the trend line. That's something you guys don't have to worry about. We also used to put in two extra lines. Again, going through this point, pivoting our pencil, pivoting the ruler on our pencil around that point, and making a trend line which was close to the steepest and shallowest of what was acceptable compared to the error bars. Now, this is how we get the computer to do this for us. I've set up a little table here for slope and intercept using linear regression. There's 4 empty cells. Click on the first one and highlight all 4 of them. The command is line ST. It stands for line statistics. Open a bracket. It tells you what to do. It says highlight the y values. These are the y values. Put a comma, and then says the x values, that's these. Put a comma. Now there's 2 more parameters. Both of them need to be true, and in computers, 1 is true, 0 is false. So I just put 1, comma, 1, then close the bracket. Before you hit enter, it's important, we want this formula to apply to all 4 of those cells. I'm holding Control and Shift on the keyboard and I'm pressing enter now. Do you see how it filled in all 4 of the cells? And when I look at the formula, there's these funny curly brackets around the outside of it. I didn't type those, Excel added them in. And it's the same formula with those same funny curly brackets in all 4 of those cells. It's called an array formula, and you have to do the Control Shift Enter in order to make it work. Now, what does this tell us that we didn't already know? Well, it tells us the value of the slope is 4.023, just like we already knew. But it tells me the uncertainty in that slope. You see, the linear regression line is a best fit line, but it's not a perfect match to the data points. The data points are a little bit off. So there is an uncertainty. The gradient of this line is 4.023 plus or minus 0.033. Now that's useful when we come to doing our calculations and analysis. The intercept, we knew that was 0.0127. We expected it to be 0. But look, the uncertainty is 0.016. So if I say my intercept is this, give or take this much, a 0 expectation for the intercept is certainly consistent with that outcome there. I have no worries at all about having a small non-zero value at the end. Now, I think I've gone on long enough for this one. That's an important feature of Excel that allows us to do more advanced analysis when we come to work out our gravity value. Thanks for watching.